Ecology Algebra, second half of 4.1, pages 4 and 5. So your general steps to find an inverse of a function is recall f of x into y. It's not really necessary, but remember that f of x is your output, so it's just y. And you switch x and y, so basically you leave everything alone, except you switch x and y, and leave all coefficients and exponents where they are, signs, only switch the x and y, and then you solve your new equation for y, and then replace it with what the f inverse of x sign. Now this only works if the function is one-to-one, so really you need to check if it's one-to-one. For example, for f of x equals x squared plus 2, if you have a miniature graph of this is just an upward facing parabola moved up 2. So if it fails the horizontal line test, then it's not one-to-one. If it's not one-to-one, you can't even do this process, so there's no inverse. Now x squared plus 2 does have an inverse over certain domains, so technically you can use a domain restriction, but we're not going to deal with that for now. That's something you can talk about later. Well, what about f of x equals 8 times x minus 2 cubed? So if we do 8 times x minus 2 cubed, to prove it's one-to-one, 8 times a minus 2 cubed needs to equal 8 times b minus 2 cubed. Divide both sides by 8. A minus 2 cubed equals b minus 2 cubed. Take the cube root of both sides. A minus 2 equals b minus 2. We don't get a plus or minus because remember a negative to an odd power is still negative. Add 2, a equals b. So this is one-to-one. So find the inverse. Change my f of x into a y. Y equals 8 times 8x minus 2 cubed. Now the same steps I did over here, divide by 8, take the cube root, and add the 2, are the exact same steps I'm going to do here when I switch x and y. So x equals 8 times y minus 2 cubed. All I did was switch the x and y. Now I need to get this y by itself. So divide x by 8 equals y minus 2 cubed. Take the cube root. So I'm going to leave it like this for now. So the cube root of x over 8 equals y minus 2, and then you add 2 to both sides. So you end up with y equals the cube root of x over 8 plus 2. Now, some people will call it the cube root of x, x to the 1/3 power, and technically the cube root of 8 is 2. So this is really y equals x to the 1/3 power over 2 plus 2, or 1/2 x to the 1/3 plus 2. So the way MyLab's plus wants your answer may depend how you do this. It probably doesn't want you to leave it like that because it will tell you it's not the most simplified form, so just be aware of that. Okay, so let's look down on page 5. There's a lot of room for the inverse of a rational. Because a rational is a lot harder. Now, it doesn't tell you to find if this is one-to-one. Just, you can only find the inverse of certain rationals, and I'm only ever going to give you one you can find the inverse of. So this is the rational. So we change f of x into y. Why this one's hard? It's because when we switch, x equals 2y plus 3 over y minus 4. We get a more complicated thing to deal with. You mean in what way? There's 2 y's now. So how do we solve this for y? Well, I'm going to multiply y minus 4 to the other side. And I'm going to distribute. So we get xy minus 4x equals 2y plus 3. Now, I need to get all of my y terms to one side. All of the y terms to one side will mean get this 2y to the left side. I also need to get everything else to the right side. So we get xy minus 2y by moving the 2y over equals, add the 4x to the other side, plus 3. What this will allow me to do is factor out the y. Y times x minus 2 equals 4x plus 3. When I do that, I can then divide by the x minus 2 over to the other side to get y by itself. So y equals 4x plus 3 over x minus 2. And I change my y back into f inverse of x. So the inverse of a rational function is another rational function. Some people will note, since horizontal and vertical asymptotes are x equals and y equals lines, the horizontal and vertical asymptote in this particular problem, they've switched. So previously, the vertical asymptote was x equals 4. The horizontal asymptote was y equals 2. Now, the horizontal asymptote is y equals 4, and the vertical asymptote is x equals 2. What you'll notice here is the only difference between these two equations is it looks like the 2 and the 4 switched places. You just have to be careful with understanding it's the asymptotes that are kind of dictating that. You can't just switch those places. This only worked because they were positive and this is a minus sign. If you want to know a trick, you can email me and ask me for how to do it, but I'm really going to have to explain it. You can't just switch those two numbers. It only works some of the time. Now lastly, let's talk about graphing an inverse. At the bottom of page 5, you have, it looks like the square root of x line, or the x squared line. But generally, if you have a graph, it's very easy to graph the inverse. Because remember, the key feature of an inverse is it switches x and y. So if you have a point on a graph, all you have to do is to find a point on the inverse is switch the x and y. And what does that mean? It means that if I've got, for example, this line, f of x equals the square root of x, looks something like this. We know it has some points. It has 0, 0. It should have the point, the square root of 1 is 1. It's the square root of 4 is 2. And then the square root of 9 is 3. If I want to find some points on the inverse, all I have to do is flip those. So when I flip the x and y on 0, 0, I still get 0, 0 on the inverse. When I flip 1, 1, I still get 1, 1. So it looks like it goes through both of those 2 points. But what happens when I flip 4, 2? It becomes instead 2, 4, which means the point is up here. What about 9, 3? It becomes 3, 9. So that's even further up, say here. So if I connect those dots, it looks like my function is going up. Now there's a few ways to remember this. An inverse is really a reflection across the line y equals x. So every point is a reflection across this diagonal through the middle. So if you like visually reflecting, that's fine. If you like swapping the points. Now, if you like words, as this goes a little bit up, so your original goes a little up and then way to the right, which is very not mathematical, but it's fine. Now, left and right are the x directions, up and down are the y directions, and again, what does an inverse do? It swaps your x and y. So it replaces every up, since up is a y direction, with an x direction. Now what's the equivalent of going up in the x direction? It's right instead of up, because that's the positive direction for x. And the way to the, instead of right, it goes up, which is the top. So you can see how words reflect. Up becomes right, right becomes up, and same thing for left and down as well. So that's just a few of the ways you can do it. Page 6 is some weird shapes. You're not going to have those on your homework, don't worry, but they will ask you to maybe reflect points. So be aware of that, and that's it for 4.1.